calculus, and it's on the first half of section 9.1, which will be on circles, our first conic section. First of all, the definition for a circle is that it is the set of all points that are the same distance from a given point in a plane. So we have one point, and we find all the points that are the exact same distance away from it. We pack them all close enough to each other, we see that it's a circle. It has to be in a plane because otherwise it would be a sphere. So again, it's the set of all points that are the same distance from a given point in a plane. The standard form for a circle when we're looking at it on a graph is x minus h squared plus y minus k squared equals r squared. The coefficients in front of these are both 1. There's a plus sign between them. And when it's in this form, then we can tell that the center is h comma k, and that the radius is equal to r. It's the square root of that number over there by itself. Of a circle that is in standard form. Again, there's just coefficients of 1 in front of these. It's a plus sign. So I can tell directly from here that the center is -5 comma 1, and the radius is the square root of 121, which is 11. Now the second one I know is a circle as well. However, it's not in standard form, so we have to complete the square. We'll look at this part of the problem first. With the x squared plus 8x, we're going to take half of the 8 and then square that. So 8 divided by 2 is 4. 4 squared is 16. So we're going to add 16 here, and we're going to add 16 to the other side. Now for the y's, half of -10 is -10 over 2. When we square that, that's -5 squared, so plus 25, both sides of the equation. Now going to the next step, when I look at the x's, I want to factor that. The two numbers that multiply to 16 and add to 8 are 4 and 4. So we're going to factor it as x plus 4 squared, and it's no coincidence that half of 8 is 4. Over here, the two numbers that multiply to 25 and add to -10 are -5 and -5. Again, half of that number. So y minus 5 squared equals, and then when we add up all of these values, that comes out to 49. Now we can answer the question. The center is -4 comma 5, and the radius is the square root of 49, 7. Here's our next problem. Again, I know it's a circle because they're both positive values. They have 3x squared and 3y squared. They're on the same side. They're both positive, so it's a circle. Our goal is to find the center and radius. First step we're going to do is to divide everything on both sides by 3. That gives us 1x squared plus 5x plus y squared plus 4y equals 5/3. Good news is that x squared and y squared are both 1. We needed that to have happen. The issue I see with this one is that the coefficient on x is odd this time. And we'll see why that's an issue, because we're supposed to take 5, divide it by 2, and then square it. Well, 5 over 2 is 2.5, 2.5, but we're going to use it as 5 halves so that when we square it, we get 25 over 4 that needs to get added to both sides of the equation. And then for our y's, half of 4 is 2, 2 squared is 4, so we're going to add 4 to both sides. Now the factoring of this x part can be kind of difficult. What two numbers multiply to this and add to that? But if you remember the pattern that we saw before, it's always half of this number, this 5 over 2 out here. If you square this, 5 over 2 times 5 over 2, that's 25 over 4. 5 over 2 plus 5 over 2 is 10 over 2. It's 5. This factors as x plus 5 over 2 squared. The y is a little simpler, y plus 2 squared. And then on the right, we need to add all these together. As far as common denominators goes, it's going to be a 12. So 20 over 12, 75 over 12, and 48 over 12. So now if we add all those numerators together, it gives us 143 over 12. So to the answer, the center is -5 halves, comma, -2. Then our radius is the square root of that number. 143 over 12 doesn't break down at all, but the radius is still the square root of that. So we have root 143 over root 12. Square root of 12 is 2 root 3. We multiply numerator and denominator both by square root of 3. That gives us the square root of 429. Multiply the denominator by root 3, that makes it come out to 6. And now we have our center and radius. Here's our next example. What I notice again is that x squared and y squared are both positive. They're on the same side. They have the same coefficient of 1/3. I don't like that coefficient of 1/3, so we're going to multiply everything on both sides of the equation by 3. It gives us x squared plus 6x, y squared plus 3y, and now that's equal to 6. We'll look at these parts individually. We have the x's and we have the y's. X's are a little bit simpler because this is an even number. Half of 6 is 3. 3 squared is 9, so we're adding 9 to complete that square. For the y's, we're going to take half of 3, which is 3 over 2. When we square that, that means we're adding 9 over 4 both sides. This is going to factor as x plus 3 squared. This is going to be y plus 3 halves squared. And then getting common denominators, 6 would be 24 over 4, 9 would be 36 over 4, plus 9 over 4, and if we add all those together, we get 49 over 4. Now to the answer. The center is -3, common -3 halves. The radius is the square root of that number, and the fact that it's an improper fraction makes it much simpler to find the square root of it. The square root of the numerator divided by the square root of the denominator, we see the radius is 7 halves.